All right, picking up from the last video, we left off on the body fat practice data set and standard deviation and variance. Okay, so we're going to go ahead and calculate those now. Okay, let's go ahead and identify our formulas here. So we want standard deviation, and we're also going to find variance. Okay? And the Excel formulas are pretty straightforward. We want standard deviation, and this is a sample. Just a note here, always assume you're dealing with a sample unless told specifically that it's a population. Okay? Almost always we deal with samples. And so then you simply select. We're looking at height, so we're going to select this column and then enter. We have 6.33 as our standard deviation. Okay? And then for the variance, we just find the variance function. Again, sample, right, dot S, and we select height again. Okay? And you get 48.13. Now, of course, you know that you could have found the standard deviation by taking the square root of the variance. And just to confirm that, you can take this to the 0.5 and you get the same number. Okay, 6.33. All right, so that wraps up the first question. All right, now let's go on to the second one. It says using the same data set as above, calculate the mean, median, and skew for each column of data. Use the Pearson coefficient and the one in Excel. Okay. So for this one, let's go ahead and, since we're going to be calculating for each of these columns, let's create rows with our various metrics. So let's go ahead and scroll down here. I'm going to insert a column here, and then I'm just going to type in what we're going to look at. We're going to have the mean, we're going to have the median, we're going to have the skew, and then we're going to have the Pearson Skew. Okay. Now, let's start out with the mean. With equals, we know mean in Excel is average, so let's select that, and we want to scroll over our data. Okay. Now, once we do that, we can, of course, drag the formula through the other cells, and now we have the mean for all of our data. Okay? And you can double check this by double clicking on any of the cells, and it will show you what it's doing, averaging, this range right here. All right, now let's go to median. Same idea. Find the Excel function median, and we're going to select our data. And then drag the formula across. Okay. We can double check it, right? Good. Now let's do the skew. We're using the skew here for Excel, and we're going to, again, scroll over our data, and then drag this across. And double check, make sure that we have the correct range. And then finally, the Pearson skew, which we calculate with a formula that we have to create, not an Excel formula. So we're going to put equals. If you recall, the formula for the Pearson skewness is 3 times the mean minus the median divided by the standard deviation. Now, we don't have standard deviation for each of these columns, so we're going to have to put that in. Let's go ahead and put a placeholder here, okay? And click enter. Now, we don't get anything because we don't have the standard deviation yet. Now, let's put the standard deviation in there. Okay. And we're just going to scroll over our data that we want to calculate the standard deviation for. And there we go. So now we have the standard deviation, which is 9.1, and we have the Pearson coefficient, which is 0.5. Now we can actually just drag both of these all the way across here. And you can pick any cell. There's your standard deviation, right, for that range. And here's your Pearson, 3 times the mean minus the median divided by the standard deviation. Perfect. So you got all your data. Now what you should see with the data is if the Pearson skewness is positive, then the mean should be greater than the median. Is that true? It's true here, right? Positive. It's true here, positive. It's true here, positive. It's not true here. The mean is less than the median. And what do you get? A negative Pearson. Then here, the mean and the median are equal. So you get a Pearson skewness of 0, which is exactly what we would expect. Okay? And here we have mean greater than the median, so we get a positive. Mean greater than the median, so we get a positive. Here you have the mean is less than the median, and you get a 0, right? But that's because it's rounded. So if I go ahead and move this out a further decimal place, I do get a negative, which is what we would expect, right? Because the mean is less than the median. The same generally applies to the Excel version of skewness. Positives imply a positive skew, negatives imply a negative skew. Okay, let's move on to the next question. It says, using the 2004 automobile practice data set, calculate the coefficient of variation for city miles per gallon for SUVs and non-SUVs. You can eliminate data lacking information. So let's go ahead and pull our data over here. And this Excel spreadsheet breaks down SUVs on one page and non-SUVs on another. Okay, so let's go ahead and determine the information we need. Well, we want to find the miles per gallon, and it clearly says we want city miles per gallon. So we're going to go ahead and highlight city miles per gallon, just so we know where our data is. And this is helpful if you have, a sheet with a lot of data on it. Here we've got over 350 different pieces of data. You want to know what column you're working in. Okay. And then what we're going to do is we're going to set up here our formula. Okay, so we're being asked to find the coefficient of variation. Okay. The problem is that the coefficient of variation requires other computations. There is no coefficient of variation formula in Excel, at least in the current time. The formula, however, if you recall, is nothing more than the standard deviation of the data divided by the mean of the data. It's S over X bar. So let's put that in here. Let's find the standard deviation of our data, and let's find our mean. And then we can calculate this. So for the standard deviation, we know and we always assume a sample unless otherwise specified, and we're going to select all of our data going up here. Okay? And we don't want the title there for this one. Okay? And then for the mean, we're going to hit equals average. Okay? And same thing. Scroll over our data all the way up. Okay? Hit enter. All right, so now we have our standard deviation and our mean, and we can from that calculate our coefficient of variation. So we know it's equal to the standard deviation divided by the mean. Okay? And we get essentially 0.25. In other words, the average variation of this data is 25% of the mean. So on average, it varies by 25%. Now we're going to do the exact same thing for non-SUVs. Okay? Go over here to city miles per gallon. Let's highlight it. Okay? And we put our data here. Let me make this a little bit bigger. And then we find our standard deviation and our mean. Okay? Standard deviation. Use the sample. And then scroll over your data. and mean, which is average. Scroll over your data. If you don't want to scroll over all the data, if you find that cumbersome, you can always just put in the rows. So P2 colon P54, and it'll automatically populate that range. Okay. And once you have the mean and the standard deviation, we can use our formula to calculate the coefficient of variation. Take the standard deviation, divide it by the mean, and you get 0.17. So if we go back to SUVs, we see that we have a coefficient of variation of 0.25. If we look at non-SUVs, we have a coefficient of variation of 0.17. So there is more variation among SUVs than there is among non-SUVs. Okay. Now, I'm going to point out that that is counterintuitive. And in some instances, you will look at your data and you will say, what's going on here? How in the world can the variation of SUVs be higher than the variation in non-SUVs? I mean, SUVs are a distinct group, right? They're similar in a lot of ways. Non-SUVs, I mean, you've got sports cars, you've got pickup trucks, you know, you've got sedans. There should be much more variation in city miles per gallon. And when you encounter that situation, you want to say to yourself, well, I wonder if I made a mistake. And if you look closely, this is of course by design, you'll find that we actually labeled these incorrectly. We interchanged our data. It happens all the time, especially when you're dealing with large data sets. So look at the cars over here. Non-SUVs, these are all SUVs. Escalade, Tahoe, Suburban. Yeah. And then if you look at what we have as SUVs, you got Volvo, Volkswagen, Toyota, Subaru. These are non-SUVs. So we have effectively switched our data, and we only noticed it when we got results that were inconsistent with our own common sense. So what we would want to do is go back and change these. Change this to non-SUV and change this to SUV, and then it would make more sense, right? Then we would see that the average variation for non-SUVs is 25%, and the average variation for SUVs is 17%. If we go back to the question, it also says you can eliminate data lacking information. Okay. If we look at the data, though, our non-SUVs, we actually do have data for all of them, right? There's a numerical value here. And for SUV, you can just scroll all the way up, and you can see pretty easily that there is data for all of our column. Okay. Now, if you're ever unsure about this, you can scroll over your data and sort it, okay, from least to greatest, okay, and that will tell you if you're missing any data. And of course, we want to sort based on, in this case, city miles per gallon. So let's scroll down, smallest to largest, and the lowest is 13, right, and the highest number that we get is 60. So you know there's no missing data, because if there was, let's put a missing data point in here. Let's get rid of this one, and let's sort again. Watch what happens. Now you'll notice you have 13 here, but when you scroll down, notice how it puts the empty cell here. You can see you're missing data. So you would need to get rid of this particular data point, or go and find out what the actual city mile per gallon is. Sometimes if you're dealing with a large data set, there is a possibility of missing data. So you might want to do this sort and search kind of function before even doing any computations. Okay, that's it for this video. We will wrap up with the remaining questions in the next one. Thanks, guys.